Was Albert Einstein actually right when he said humanity would never be able to witness the edge of the universe? For decades, that idea sounded like a poetic mystery, until now. The James Webb Space Telescope has just revealed something strange. A massive void near the very beginning of time itself. This discovery might be more than just another weird cosmic phenomenon. It could actually support Einstein's bold claim. But what exactly is this void? Is it just an empty patch of space, or could it represent the very moment creation began? Scientists are now rethinking everything we thought we knew. A strange void spotted near what we call the dawn of time has left astronomers stunned. This region is so distant, so ancient, and so peculiar that some believe it could prove one of Einstein's most mysterious predictions. Over a century ago, Albert Einstein said something remarkable, that mass and energy are just different forms of the same thing. For most people, that's a tough idea to grasp. But now, this ancient cosmic void might be giving us a new lens to understand exactly what he meant. And maybe more surprisingly, it hints at the possibility that some things in the universe will forever be hidden. Back then, astronomers began peering outside the Milky Way with primitive telescopes. They saw fuzzy, cloud-like patches in the night sky. At first, they thought these were just gas clouds. But over time, it became clear that these weren't just random wisps of gas, they were entire galaxies. First, they noticed the small and large Magellanic Clouds, then the mighty Andromeda Galaxy. What followed was nothing short of a revelation. The universe wasn't just large, it was staggeringly vast, filled with billions of galaxies, each containing billions of stars. As this discovery unfolded, new theories began to emerge. One of the most important breakthroughs came from Edwin Hubble, who realized that galaxies were all moving away from us. This led to the concept of an expanding universe. Around the same time, Georges Lemaitre, a Belgian physicist, introduced what we now call the Big Bang Theory, the idea that the universe had a definite starting point. Albert Einstein, already a legend for his theories of relativity, watched these developments unfold. Many of his earlier, abstract predictions were starting to look real. But even then, Einstein wasn't completely convinced about the universe's beginning, or its end. Despite his acceptance of the Big Bang Theory, Einstein had one firm belief. Even if the universe did begin with a bang and even if it might someday end, humans would never be able to actually observe either event. No matter how powerful our telescopes become, he thought the edges of time itself would always remain out of reach. And strangely enough, more than 100 years later, the James Webb Space Telescope may have found something that supports this eerie idea. A cosmic void so deep and strange, it challenges what we think is observable. Einstein's reasoning was surprisingly straightforward, at least for him. He gave two main explanations for why the start of the universe would remain forever hidden. First, he pointed to the nature of the Big Bang itself. According to our best models, no light existed for hundreds of thousands of years after the universe began. This lightless period is now known as the cosmic dark ages. If there was no light during that time, how could we possibly use telescopes, which depend on light, to see anything from that era? Even modern instruments like radio telescopes, which can detect waves instead of visible light, hit a wall when it comes to peering past the dark ages. And sound? That's impossible in space. Sound waves need a medium like air or water to travel through. In the early universe, space itself didn't even exist yet. There was nothing for sound to move through. Scientists agree, the Big Bang didn't make a sound. It happened in silence. Completely quiet. So not only can we not see the beginning, we can't hear it either. In the 1960s, scientists discovered something called cosmic microwave background radiation. This is essentially the afterglow of the Big Bang, a faint whisper of light that still lingers in the universe today. It's an important clue, no doubt. But it doesn't show us the actual event. It's like seeing smoke after a fire. You know something big happened, but you didn't witness the fire itself. And that, Einstein believed, was the closest we'd ever get. We could never directly observe the true beginning. His second reason had to do with the nature of space and time. Einstein believed that as the universe expands, its origin point keeps receding farther and farther away from us. Like a balloon being inflated, the center stretches and moves in all directions. The more we look, the more it moves. On top of that, Einstein suspected that space might actually be curved. If that's the case, then the start of the universe could lie beyond a kind of cosmic horizon, hidden forever. The edge would never appear in our view no matter how far we looked. Keep in mind, Einstein came up with these ideas at a time when telescopes were still blurry and weak. Back then, we could barely make out galaxies close to us. Now we've cataloged millions of them. Our universe turned out to be even bigger than we imagined. And with the James Webb Space Telescope, we're seeing farther and clearer than ever before. In fact, the telescope allows us to look back nearly 13.6 billion years, almost to the moment of the Big Bang itself. But still not quite. The final barrier remains just beyond our reach. And that's where this strange void comes in. Among its many discoveries, the James Webb Telescope recently found something odd: a vast, seemingly empty region of space. At first, scientists thought this void might be related to the cosmic dark ages. Maybe it was a snapshot of the time before stars and galaxies had formed. That would make sense. But the more they studied it, the more confusing it became. It wasn't just an ordinary empty patch. It was too vast, too strange, and too isolated. Voids in space are already puzzling. Even nearby, these regions, where there are fewer stars and galaxies, challenge our models of how the universe works. But to find one at the very edge of the observable universe? That throws a wrench into everything we thought we knew. The Big Bang theory assumes that the early universe expanded uniformly. It should have been mostly the same everywhere. A void like this shouldn't exist, not if our current understanding is correct. Now, this doesn't directly prove Einstein's ideas, but it does support the feeling he had, that something about the beginning is fundamentally unreachable. Even with our best tools, we still can't find the origin. What if this void is more than just a random gap? Could it actually be the beginning itself? There's no proof of that. Not yet. But we also don't have any proof that it's not. In the absence of answers, speculation grows. And when it comes to voids, the speculation can get wild. Some scientists believe these regions may contain invisible matter, like dark matter or dark energy. Others propose even more radical theories. Maybe voids are remnants of past universes, scars left over from cosmic collisions in a multiverse. Or maybe, just maybe, they're not empty at all, but filled with things we simply can't detect. There's even a hypothesis that advanced civilizations might be draining energy from these regions. Others think voids could be portals to parallel worlds. If hypothetically our universe did form from such a void, we're left with an even bigger mystery: how did matter come into being in the first place? That leads us to the idea of a singularity. A singularity is a point of infinite density where the laws of physics stop making sense. All the known forces, gravity, electromagnetism, nuclear energy, would be smashed together in a singularity. Space and time wouldn't just bend. They'd collapse. The entire universe would be compressed into something smaller than an atom. According to one theory, this singularity was perfectly still. Nothing happened until one tiny fluctuation broke the balance. And from that disruption, boom, the universe was born. From a single point of pure potential, stars, galaxies, and even life itself emerged. But here's the catch: if this singularity was truly nothing, then we might never be able to observe it. It could be forever invisible, impossible to detect. In that sense, Einstein might have been absolutely right. Interestingly, we see similar singularities in black holes. At the center of every known black hole is believed to be another singularity. A place where gravity is so intense not even light can escape. These black holes likely form when massive stars collapse after they die. That's the standard theory anyway. But again, no one has ever actually seen the center of a black hole. It's a cosmic blind spot. Just like the beginning of the universe. All we have are equations and theories. Now, things get even more complicated. The James Webb Telescope is beginning to shake up our long-held beliefs. It's found galaxies that seem far too old to fit the Big Bang timeline. If these findings are correct, then our entire model of the universe may need revision. Could the universe be older than we thought? Or did it begin in a way we've never imagined? Maybe the laws of physics change near the beginning of time. Or maybe time itself isn't what we think it is. Black holes, voids, and cosmic origins all share a common problem. They resist observation. We can't look directly into a black hole. We can't see the Big Bang. And now, even the most advanced telescope in history can't crack open the mystery of the void. But that's not stopping scientists. They're turning to something new: artificial intelligence and supercomputers. These systems are being trained to recognize patterns and simulate the birth of the universe. Some of them even use water-based storage chips or quantum logic to unlock processing power we've never had before. If these systems succeed, they might help us answer the ultimate question: where did we come from, and what lies beyond the edge of the universe? Until then, the void remains a silent echo. A reminder that some mysteries might always be just beyond our reach.